Let's take this question. It says from the diagram above, calculate the total current in the circuit. Calculate the total current in the circuit. So before we calculate the total current, let's analyze the circuit. What we have here is a 12-ohm cell or battery. 12-volt battery, 12-volt battery, which is the source of the energy in the circuit. And here we have our resistor 6 ohms, another resistor 12 ohms, another resistor 18 ohms. And you can see the three are connected in parallel, meaning that they are sharing the same terminal, the same front and the same back. The front of this one, fronts are all connected to the same terminal here. The back are all connected to the same terminal here. So this is a parallel connection. And then I also remind us in some theories about series and parallel connections. For this parallel connection, each of these resistors sees the same voltage. Since they are sharing the same terminal, the voltage across each resistor will be the same, which is 12 volts. But the current that will be passing through each of them will be different. So that's why you see the label here, I1, I2, I3, meaning that the currents are different. The current will depend on the size of on the magnitude of the resistance. And here I means the total current. So when a current is drawn from this battery here, as the current comes to this terminal, it will share into three. To share into three depending on the size of the resistance. The one with the highest value of resistance will have the least current. The one with the lowest value of resistance will have the highest current. So that is it about here. So now let's go into analysis. So there are two methods to do this. So let's go with the first method. Now we are going to calculate the total current, which is this I here. So the total current I, since it's a parallel connection, total current can be given as the summation of the individual currents through each of this branch. So that is I1 plus I2 plus I3. So now, how do we know I1? You recall all that from Ohm's law, that V equals to what? IR. So if you make I the subject, I equals to what? V over R. So now, since the currents are different, the current will depend on the magnitude of the resistance, but the voltage will be the same. So that means our total current, this I1 will be V, because the voltage that is seen is 12, will be V over the resistance there. So let's first say V over R1 plus I2 will be what? V, because it's seeing the same voltage, V over R2. And then I3 will be V over R3. So this will give us 12. So if we substitute now, we will be having 12 over 18 plus another 12 over 12 plus 12 over 6, which equals to, this can be written as 1 over 18 plus 1 over 12 plus 1 over 6 times what? 12 outside. Or if like that is too complex, you can still follow the normal procedure here. 12 will cancel 12, 1. 6 will cancel itself, 1 cancel 12, 2. 6 will cancel here, 2, and cancel here, 3. So this is the same thing as 2 over 3 plus 1 plus 2. Any way you want to go about it, it's still the same. So the LCM there is 3. This is the LCM. 3 divide 3, 1 times 2, 2, plus 1 divide 3, 3 times 1, 3, plus the denominator of this one is 1, 1 divide 3, 3 times 2, 6. We're talking about I here, equals to 6 plus that 9, 10, 11, that would be 11 over 3 amps. And if you convert that to decimal, that would be 3.66 amps, which is approximately 3.7 amps. So that's P. That is P. So the next method that you may want to use to do this is you calculate the equivalent resistance first. And if you calculate the equivalent resistance, that's by doing 1 over 18 plus 1 over that is by doing this. Whatever it gives you will now be, you know that your current I will be voltage over resistance. So that will be total voltage over equivalent resistance. So if you calculate the equivalent resistance first, that will be 12 divided by that equivalent resistance will still give you the same thing. Thank you.